Here we are. So we're recording. Are you saying no one will show me their face so at least I see how nice you guys look? Wait, 13 participants. Guys, we have another ghost. Is that Brandon again? Okay, anyway, so we had a test the last time, and I've been going through your papers. I have to be sincere. I still have one or two to check, and by tonight, in the next couple of hours, it will be ready. But I've seen a lot of performances, like nice, let's say very nice workings. I've seen grade 6, I've seen 5, I've seen 7, I've seen 6, I've seen 3, and so on and so forth. So the least I've had is 3 out of 7. No one is graded 1 or 2 so far. So I'm going to tell you some of the mistakes that I've noticed that are common to what people have. Let me see if we can change this background. And I'm trying this. The last time we had any outbreak that I had to teach students like this was during the Ebola when I was in Nigeria. So this is kind of new. Okay, this is better than my desktop, right? So that's going to be our whiteboard. That's what we shall be using. This will be our pen. Okay, so let's reduce that so we can maximize the whiteboard. So I'm also going to reduce this. So please notify me if you have any questions. This is how it's going to be for now. Okay, so for question 1, in general, I believe everybody has a question. Hello, does everybody have the question? Nope. Okay, Krista Q. Karen has a question. Okay, let me see if I can send it to everyone. I'm supposed to have it on the, can you go to your Google Drive and where I usually post the question? Make sure you have it ready on your computer. Edmodo, did I put it on the Edmodo? Yes, I think I posted both the question and the answers on the Edmodo. So everybody please check that now. Edmodo. I hope the video is okay. I enabled HD yesterday, so yeah, still HD. All right. Okay, Edmodo, Sam on Edmodo as well. So if you go to the last thing I posted, I guess, yes, mathematical proof, problems and solutions. So I'm also going to download it now. Problem, and this is the solution. So for question 1, we are to write the converse, the inverse, and contrapositive of the following statements. Everybody did well on this, and of course you have seen this, so we're not going to waste time on that. Let's move to 2. I said use a counterexample to disprove that for all, I believe everybody can see my desktop. Just 1 or 2 people to reply to that is okay. Thank you. All right, so using counterexample to disprove that for all prime P factorial plus 1 is a prime. Like I said, you just need a counterexample. So like I said, I rated each question 7 points, just using IB as final grade. And I've seen, let me see, an error that I noticed somewhere. maybe not here. Anyway, I'll just explain with my mark scheme first. So the statement is false because when P is 5, I think somebody used when P is 11 as well. So all you have to do is pick a prime and explain, show that P prime plus P factorial plus 1 is not a prime. That's all you have to do. So it's as short as what you can see on the screen. Okay, as simple as that. Let me go to the, so for instance, when P is equal to 5, sorry about that. Like purple, where's my purple? That doesn't look purple. Anyway, whatever. Let's take this. So if I pick P is equal to 5, all you have to do is, this is the prime because the hypothesis says P is a prime, but P factorial plus 1 is also a prime. You just have to pick 1. So I pick 1, P is a prime. So P factorial plus 1 will just be 5 factorial plus 1, and this is 121 because P factorial, 5 factorial will be 120, and this is not a prime. So you just have to conclude by giving us 1 and showing this. That's all you have to do. Okay. I think somebody was trying to work. Somebody gave me P factor P is a prime and P factorial plus 1 also gives a prime. That's not a counter example. Remember, the statement says for all. So you are supposed to justify that the for all is wrong. Okay. For all, that's what you want to justify. Okay. So please take note of that. Let's go back to, yes, let's go back here. Does everybody get that? Most people, of course, gave me example and that's it. This is all you have to do to get the 7 points on this one. I wrote some comments, and lots of you, I wrote comments for you. Some of the comments, I'll read them out. Of course, I won't mention names. So somebody said, does for, not for all P in Z, if P is a prime, blah, blah, blah. Then I put it in code. I said, does not for all P in Z is, yes. It's just the grammar, basically. So somebody pick P is equal to 5, then said P factorial, this person got 121, which is not a prime, then trying to conclude the statement by saying therefore. So the person used does, which is okay, does not for all P in Z. If P is prime, then P factorial plus 1 is a prime. So I just said, this is better. Does not for all P in Z, or not for all prime P in Z, is P factorial plus 1 a prime. So it's just maybe statement construction, basically. There's no error here. The next question, because I'm using the trial version, I think this will last for say 30 or 40 minutes max. Since it's working perfectly, I might subscribe for the non-trial version, which should be cheap actually. Then we can go for a longer class discussion. Okay, so I may need to stop the meeting and we may need to join again because each meeting will be short. All right, so let's see. I can't even see how long we've spent on the meeting to see how fast I need to be. All right, next question is, prove by contradiction that if x is real and positive, of course, x plus 1 over x is greater than or equal to 2. Now, for contradiction, you have to begin with the opposite. So look at how I put it in the mark scheme. If x is real and positive, it means x is greater than 0. Suppose on contrary that we do not have the result. Your contradiction will be you changing the outcome, not changing the beginning. Okay? Because some people made that mistake in 1 or 2 questions. They're trying to solve by contradiction by changing the hypothesis instead of changing the outcome. Hypothesis is the if part. The outcome is the then part of the statement. Okay? Remember, we've talked about conditional statements having the antecedent and the consequence. If this happens, then this happens. The if is the antecedent, then is the consequence. So when proving by contradiction, you maintain your antecedent if, you only change your consequence to the opposite. Oh, suppose I maintain this antecedent, but contrary, I have this opposite conclusion or consequence. Okay? So that is why the question says, if this happens, X is real. So we didn't change that. Then this is what you need to change. Opposite of greater than or equal to 2 is less than or equal to 2. And here is Y. That's my whiteboard. Okay. So this is why. Let's, instead of deleting that, I can pick another whiteboard. Let's remove that. There's no need to save this yet. We're gonna need cleaner to Krista to clean the board for us sometimes. Krista, will you be able to help? Like you always do in the class. All right. So we have a number line here, for example. This is 0, this is -1, this is 1, this is 2, this is 3. The statement is about greater than or equal to 2, isn't it? Which means from here to here. If it is not, then it should be this way. And we are talking about, let's say, okay, if it is not, then we will be dealing with something from here, at least, okay? So if you have greater than, if X is greater than or equal to 2 is to be reversed, it should be X less than 2. If X is greater than 5 is to be reversed, then it should be X greater than, less than or equal to 5. Does that make sense? Okay. So that is the one of the mistakes that some of you made. Okay. A lot of you, some of you were trying to do the contradiction, but rather than having that less than, I was saying less than or equal to. That is an error. So it's a minor mistake, so which sometimes I just penalize a little bit, but you have to take note of that. So let's go back to the solution. So all you have to do is this. So if we change that, we can multiply through by this. And the only reason we are able to multiply without changing this sign, can you see my cursor, please? Can you see my cursor? Okay, good. So the only reason you are multiplying without changing this is because you are multiplying by a positive number, which is part of the hypothesis, okay? That X is positive. So if you multiply through by positive, inequality sign is not altered. So, and that's why you have this. If this condition is not there, then it will be wrong for us to assume we can multiply through without changing it. And if you multiply and you change it, that would be wrong as well, because that means you have assumed that it is negative. So assuming is not a good thing. It's a wrong assumption. So when you bring this together, you realize this is actually a perfect square, X minus 1 squared. A lot of you did this. Some people did not do it this way. Some people did it in another way. I read it. Some people, I gave them a 7. Some people probably got less than 7. So why is this a contradiction? X minus 1 squared is less than 0. It's a contradiction. Anything less than 0 is negative. And there is no square number that is negative, except if you square a complex number. And why are we not considering that? X is in R from the beginning. X belongs to R. So there is no way you can square X minus 1 square and it will be less than 0. Worst case scenario, it will be equal to 0 because X can take 1. If X takes 1, then the 1 minus 1 square will be 0. But here we are dealing with less than 0. Okay, so this is a contradiction. Definitely you have assumed wrongly of your conclusion and above, so you change it back. I'll give you some of the ways some people did it. This is a contract. So somebody did it up to this point. here, okay? And said, this is a contradiction because x is positive, then x squared minus 2x must be at least equal to or greater than minus 1. Why didn't you next time say must be greater than or equal to minus 1? I guess what this person is trying to say is that if x is 0, for example, no, it says x greater than 0. So this person have assumed that the first value to test is 1. So if x is 1, then this person said minus 1. That's not entirely true. Your x could be 0.01, you know. It says greater than 0. It never said x is an integer. So that's a wrong assumption. So if I check 0.1 squared minus 2 times 0.1, I'll be getting, okay, just a minute. I'll be getting minus 0.19. Okay, so it's not going to be greater than or equal to minus 1. So this would be wrong to assume. Okay, that's one loophole for you to take notes. Another one that I saw here is, okay, after getting to this point, I'll go back to, where is that? Again, the board. Yeah. Okay, I think I'm going to need, just a minute. Okay, yeah. So we don't have to clean the board since Krista is not going to help us. All right, Mr. B, all the time. Okay, no problem. So we have to agree on the time tomorrow. We need about 1 hour to meet. So I chose 6 today because I didn't know your time zone, if everyone is in Macau or not. If you are all in Macau, then good, we don't have a problem. And then we can meet in the morning early. Of course, it's not going to be 7 a.m. because I know some sleepyheads among us, including me. Anyways, so what time would be best in the morning? We need to talk about that. Now, having said that, I just chip in that because Mr. B is leaving at 7. Okay, so quickly, somebody said this. So after getting to this point, x squared plus 1 less than 2x. Somebody did x squared. Don't mind my writing. I'll use the table next time. Less than 2. After getting to this point, then somebody said, if x is 1, this would not work. I don't know why you had to do that. So, because if x is 1, somebody said 2 less than 2. It's a contradiction. I get it. But remember, we have already said this before. If you are proving, you prove in general. You don't prove for one case. So your proof should be in general. So because this person could not argue completely, this person got a 3 in this particular proof. Okay? So these are some of the minor stuff. Let me see if there's another one. This is a 7. Okay, this is a 6. Yeah. Somebody, after getting to the point of contradiction, run out of time, we've removed the 40-minute limit on your group. I love it, thank you. Okay, so quickly, this is what somebody else did. I'm getting to this point. From x plus 1 over x is less than 2. Can everybody still see me? From this point, somebody put them in cases. Case 1, if x is positive and even. Case 2, if x is positive and odd. This is not necessary. This is not necessary. For the case of positive and even, so this person assumed x is equal to 2k, which is the format for even number, and end up getting 4k squared plus 1 is less than 4k, and said which is a contradiction. If x is real and positive, then how does this person know is a contradiction? This person now stated that, oh, let k be 2. This is still concrete cases. is not general cases, so it's not a good way to prove. Okay, what you could have done here, whoever this person is, of course I know the person, what you could have done here is, this is also a perfect square if you bring everything to this side. So with your 4k squared, I'm gonna have to hold that screen. With your 4k squared plus 1 equals that, less than that, you could have said 4k squared minus 4k plus 1 is less than 0, which could have given you 2k minus 1 all squared is less than 0. And you could have told us that a square number cannot be less than 0. Okay? Because anything less than 0 is negative, which is the same as just doing what you should have done in the beginning, which is, okay, I think I erased that in the beginning, which is from here. Instead of going through this, from here, you could have just arrived at the right solution like this and just conclude. Okay, so whoever that is, please take note. And this person did the same thing for the second case. The second case, because it's case 1, case 2, this person is trying to use proof by exhaustion while trying to do contradiction, which is, you know, a good way of thinking. So this person assumed that what if x is 2a plus 1, which is the case of odd, and this led to the point 2a plus 1 squared plus 1 is less than 2 times 2a plus 1. This is not necessary also, because if you bring that again, you're going to end up getting 2a plus 1 minus 1 all squared, less than 0. Agree? Which is, again, similar to the other one. So, and of course, I see something like let a be 2 again. Whenever you are proving, except proof by disprove by counterexample, that is the only situation you have to state let a be 4, let theta be 10 degrees, and so on and so forth. In any other proof, you are not supposed to do that. So that's that about that. Let's move to the next one. Does everybody get my point, please? Okay, thank you. So let's move to the next one. Okay. So for the next one, okay, by direct proof now. So the same problem by direct proof. I think most people did that quite well. On these, I have certain comments. I have certain comments. Mr. B, if you need to leave at 7, that's okay. So that if anyone is not leaving except you, we can move on. And since we are all in our bedroom, drinking coffee with friends somewhere, then it should be easy for us to just learn some things in our comfort zone. It's even easier for me since I'm home on my lazy bed, as you can see. Remember this bed? You guys sat there when you guys came the last time. So that's my lazy corner. Don't tell anyone I said that. Otherwise, you're in big trouble. Okay, got it. What, Lillian? What did I do? Yeah. Are you leaving also? Don't you dare. Okay. What happened to him? Is he leaving? Mr. Chang? If he's leaving. No, that's for Brandy. Brandy is the one leaving, not Ethan. I am okay. I know you're okay. You're always okay. Always okay. All right. Okay, let's move on. So for question 4, direct proof. Now, this is another mistake, and I've noticed that in about 2 different questions. So I'll go straight to it. Remember, the statement says, if A is less than B, then this happens. When you are doing a direct proof, which is the proof by, what is that other name for it? When you're doing the direct proof, please start from the if part, okay? And make sure you arrive at the other part. Some of you started from the other one, which means starting from a plus b less than a plus b over 2 less than b and arriving at a less than b. That is you doing the converse. So this is one case. Suppose to contrary. Yeah, that's contradiction, sorry. Okay, number 5. What's number? I mean number 5, not number 4. Okay, this person did it perfectly. Number 5. Aha, somebody did equivalence. But the question was clear. Proof by direct proof. Do you guys get me? So somebody did equivalence. Okay, this is not acceptable. Okay, if A is less than B, then this happens. Then this person said A is less than B if and only if that happens. So I'll give you what I have now. So let's come to the board with me. Oh gosh, I love technology. Don't we all? Living for dinner, foodie. Such a foodie. That's all right. Okay. Trying to see if I can reduce the length of the board itself. Oof. Anyway, can you move the board? Yeah, okay, great. Okay, it's our first time. There's going to be 1 or 2 things we're trying to know about this stuff. So hopefully the next one will be okay. All right. So this is what somebody said, which is not acceptable. This is about question 5. So the statement somebody is trying to prove, if A less than B, then A plus B over 2. You know, my handwriting is more beautiful than that, so please don't judge me. Okay. So this person said this implies that A less than B if and only if A plus B divided by 2 is less than B. This is equivalence. That's not direct proof. So this person said this implies that if and only if, so by multiplying both sides by 2, so we have 2B, and then this person said it implies that A less than B, which means when you subtract B from both sides, and then this person concluded that therefore, if A is less than B, then A plus B divided by 2 is less than B. This is wrong. So I said, why equivalence? By direct proof, start with A less than B and use that to get the results. That's all you have to do. Does everybody get that? This is wrong. So this is graded a 2. Okay? So all you have to do is start from A less than B. And what do you do to both sides? Add B to both sides. Yes? Because we are trying to prove A plus B. Add B to both sides. So this is 2B. And divide both sides by 2. A plus B divided by, it's equal to that. That's all. So I started from the if part and I concluded in the then part. This is what we call direct proof. Okay? So please take note. Does everybody get that? When I give you your papers or when I scan it to you, you will know who I'm talking about. So please take note. Then another error is this. The purpose of this is to discuss the major errors actually, okay? The major errors. So we do not commit the same or make the same mistake next time, okay? Another mistake that I noticed is this. Somebody said direct proof. Now watch this, direct proof. A plus B divided by 2 less than B implies that A plus B is less than 2B implies that A is less than B. Can somebody tell me what is wrong in this direct proof of the same question? Quickly, anyone? This is somebody's solution, also graded as 2. Goes the opposite way. Thank you, Mr. Cheng. Exactly. Start with from hypothesis. Exactly. You're supposed to start with the hypothesis and not from what the hypothesis led to. Actually, this is another person who did the same. So 2 people did it that way. Question 5. Yeah, this one did it perfectly. And so on. So that's that about question 5. Please let us take notes. Whenever you are doing a direct proof, start from the hypothesis, then make sure you arrive at your conclusion. Okay? Now, 6. Prove that for all integers n, if n square is odd, then n is odd. That's question 6. So I did 2 ways in the solution. You are welcome to do any of the 2, or if you have another way of doing it, I think somebody attempted a direct proof. If it is read and is seen to be okay, then it's perfect, all right? So we can do contrapositive. Remember, we talked about contrapositive, which is like the converse of the inverse, right? So by contrapositive, the statement, which originally says, to avoid me opening back and forth, since you have the question on your screen as well. The statement is if n square is odd, opposite of that would be if n square is even, right? Then n is odd, opposite of that would be n is even. So the contrapositive would be the other way around. So we start from the second part, right? So the contrapositive of that statement would be if n is odd, then n square. If n is even, then n square is even. So you can do that. Remember, in your contrapositive now gives another if-then statement. So when proving the contrapositive by contrapositive, after you state your contrapositive, you prove that contrapositive using a direct proof now, in most cases, okay? So the contrapositive of if n square is odd, then n is odd will be if n is even, then n square is even. All you have to do is pick an even number and use that to justify that n square is even. When I say pick an even number, I'm not saying concrete numbers. I'm talking about a generalization like this. And that is what we have done. So you could see that we pick, I'm going to use the cursor now, we pick n as an even number, okay, and we stated that k is an integer, then it implies this, and this is also even, and that is the all. That's all about the proof. We can also use contradiction. When using a contradiction, we leave our hypothesis and only focus on the results. We change the results. Remember, the question is if n square is odd, we maintain that. The result should be n is odd. We now change that to but n is even. Suppose on contrary that n square is odd but n is even. That is the contradiction now. So because we said that n is even, so pick that even number, substitute, and you realize that your so-called n square is not odd, and that is your contradiction, okay? So a lot of you did it in different ways, which is absolute. Let me see if I can see few comments, if I talk. Okay, I wrote a comment here for someone who used contrapositive. And contrapositive, this person said, if n is even, then n square is even. But guess what? This person now picked n is equal to 2k plus 1, which is wrong. You are assuming that n is even, then you pick n is equal to 2k plus 1. So I wrote in the margin, you just said if n is even, so n is equal to 2k should be used. So this was not graded as, I think I graded this as 1 because I only awarded for the fact that the contrapositive statement is correct, okay? That's question 6. I wrote another comment for someone. Again, you have just attempted to prove if n is odd because this person did this. The question is if n square is odd, then n is odd, which means your if is the n square. Your result should be on n. So what this person did was trying to do a direct proof by assuming an odd number, 2n plus 1, and showing us that n square is odd. Do you understand that? If you use direct proof, you are supposed to begin with n square is odd. I don't know how you want to do that. Maybe you assume that n square is equal to 2k plus 1. But then what can you say about n? It will be difficult because by the time you take the square root of that, it's not going to be convenient. Okay, but we can try. So this person was also graded 2 because what this person tried to do was to assume n is odd and justify that n square is odd. No, that's not what the statement is asking. That is proving backward again. Okay, this person, so just few errors in this case. I believe this is clear. Can I get a yes from 1 or 2 people so we can move on quickly? Someone is leaving in about 7 minutes. I'm aware of that. Okay, thank you guys, thank you. So proof by exhaustion. Yes, this is a very sweet one, very sweet, very sweet. All right, exhaustion. So many of you attempted this, very good. So this is similar to what we did in the class, remember. Now, you start by saying the reason why you are using the form n equals 3k, 3k plus 1 and 3k plus 2. That's the first thing. You need to tell us why. The reason we are assuming this n can be either of these 3 cases is the first statement. For any integer, if any number is divided, if any of this integer n, okay, n is an integer, right? Whenever you divide that integer, which is any integer by 3, your remainder will either be 0 or 1 or 2. If the remainder is 0, then it will be of the form n equals 3k. If the remainder is 1, it will be of the form 3k plus 1. And if the remainder is 2, it will be of the form 3k plus 2. That is the reason we are assuming those forms. So many of you, like I noticed, just assume those forms without telling us why. You should always begin with why. I overlooked that, and of course, I gave you your 7 point because it was proved logically and sensibly. Just that beginning was faulted. But please take note next time. Now, somebody actually gave me 5 cases. Yeah, 5 cases. Let all integers n be. No, you are not letting the integers be that. There's a reason the integers will be that. You are not assigning it yourself. It's there. You just need to tell us why it is there. Somebody said, let all the integers be 3k minus 2, 3k minus, and I get this. I get why this person is thinking this way, but this young lady, whose name I'm not going to mention, of course, forgot this fact. So she claimed that all integers will be of the form 3k minus 2, 3k minus 1, 3k, 3k plus 1, 3k plus 2. Actually, these are 3 forms written in 5 because this is exactly this and this is exactly this, and I'll tell you why. Let's pick k as 5, for example. Then you're going to get this to be 15 minus the, which is 13. Isn't that the form that leaves a remainder of 1 when it is divided by 3? Does everybody get that? Also, let's pick k as 7, okay? Put it here. That will be 20, isn't it? 20 leaves a remainder of 2, so it's in this family also, okay? So stating these 5 cases is a repetition because this and these are already here. So that is why you only stick to this only, these cases. Okay, so you only need to prove 3 cases, not 5. So for this person, I wrote no need for the first 2 and the other 3 were perfect. Also, I noticed that some of you gave yourself too much work by substituting your 3k into n cubed plus 2n. This is just giving yourself unnecessary stress. Because by the time you substitute this binomial, for example, look at what happens when you substitute this. This is expanding, you know, of course, 3k plus 1 here. This is bigger expansion. What is the best thing to do to begin with? Anyone? Rather than to avoid this expansion, what is the best thing to do? Hello? Anybody home? Hello? Factorize. Thank you, Nakita. All right, please, I need guys to respond in real time so I know that everyone can hear me. Okay? Factorize, that's the best thing to do. Because when you factorize, thank you, Nakita, for that. So when you factorize, you get n into n squared plus 2. And it's easy to expand 3k plus 1 squared, which may not even be necessary, because if you put it here and okay, you can put it here and it works. Okay, if you expand this, you're just going to get plus 1 and plus 2 will be 3. Then you're good, right? Because the expanding this square will just be 9k squared plus 6k plus 1. Okay, and by the time you add these 2 to that, you get your 3 and you factorize. So please avoid this stressful kind of solution. Another error that I noticed, minor error. Remember, we put the form n is equal to 3k. You can use 3t, 3t plus 1 and 3t plus 2. Okay, just that k is just the first thing that comes to my mind. I noticed some people use something like, oh, the numbers will be in the form 3n plus 1 and 3n plus 2. No, the focus is on n. Okay, so you are trying to tell us every integer n can be written in certain form. That certain form, you should use another parameter, not same n. So use something like k, t, m. If your name is Krista, if your name is Thomas, if your name is Mary, you know, you can use d if you want. Okay, bye guy, bye Mr. B, and so on and so forth. Okay, if your name is Nakita, okay, don't use n. Nakita can't work in this case. All right. Krista, because we use Krista. Leo, as long as your L doesn't look like 1, and so on and so forth. Clarissa, if you like, can use your name C. Okay? So please take note of that. That's another minor error that I noticed. Every other thing looks okay. Does everybody get the 2 errors that I stated here? Please, can I get a yes from 1 or 2 people? Thank you, thank you, thank you, thank you. And please avoid unnecessary expansion like the cubic expansion especially. You want to give us a very not too long a proof, logical, straightforward, not too stressful to both whoever is proving it and the reader of your proof, all right? So you want to do that. That's how math is. Okay, quickly now. Let's go back to this one. So quickly, prove that the difference between 2-digit numbers, this and this, is always divisible by 9. Okay, wonderful. Now, the reason it was put in quotes, you can see my proof is very short. The reason it was put in quotes is for you to be able to differentiate between in algebra, if you write AB, it means A times B, isn't it? So we are trying to avoid, in a 2-digit number will be written as, say, 19. Of course, this doesn't mean 1 times 9. Okay? So in mathematics, or the way mathematicians will write is for you to, so when you write something like this, we're trying to tell you it's a 2-digit number. Okay? And a 2-digit number like 19, for example, maybe I use 39, it's 30 plus 9, which is equal to 3 times 10 plus 9. Actually, this means if you write it in place value, you say 3 tens and 9 ones or 9 units. So this is 3 tens. Okay, so this is 9 times 1. 3 tens and 9 ones. Does everybody get that? Okay, similarly, if you have like maybe 78, it will be 7 tens and 8 ones. Okay, so this AB means A tens and B ones. And similarly, the reverse, BA will be B tens and A ones. This is all you have to do to begin with. Okay, so the question is telling you that the difference is always divisible by 9. Of course, somebody did 2 cases for me by assuming that AB is greater than BA. So for your AB, which is 10A plus B, this is the real form. For your BA, which is 10B plus A, which is the real form, okay? So somebody did 2 cases. Case 1, if this is larger, so AB minus BA, which is like saying maybe 45 minus, 54 minus 45. That's in this case. So if AB is this and if B is that. So this person was trying to do 2 cases, okay? And then this will be 10A plus B minus 10B plus A. And at the end, you will get something like 9 to bracket something. Of course, it's going to be 9A minus B. Am I right? So 10A plus B minus 10B minus A. Yes, so that will be 9A. Krista, you're not doing your job by cleaning the board. You're fired. Okay, so this is going to be 9A minus 9B. So that will be 9 brackets A minus B. And since A minus B is an integer, then the result follows. That is the difference, because this is the difference now. The difference is divisible by 9. So, and then this person else, that somebody said this is case 1 and also did case 2. Okay. And decided to do it the other way, and eventually we'll probably get 9 into B minus A and also prove that that's also okay. But if you didn't do the 2 cases, it's actually perfect, because if you say a difference doesn't have to be a positive difference. Your difference can be negative, okay? And if the positive difference of a number is divisible by 2, the negative difference will be divisible by 2. Do you understand that? So if you do just 1 case, it's fine. That's the point I'm trying to make. The 2 does not have to appear. So misconception and comments, just 1 or 2. So of course, this person got a 7. After getting to this point, all right, somebody wrote, since A minus B is an integer, so it is a multiple of 9. The grammar is a bit confusing. Since A minus B is divisible by 9. Remember, you said since A minus B is an integer, sorry. Since A minus B is an integer, so it is divisible by 9. What is it? That's my question. What do you mean by it? If I say, since Krista helps to clean the board, so she is a good girl. When I say that she, you already know I'm referring to who? Krista, isn't it? So in this case, I know what this person is trying to say. Of course, this person got the 7. Since A minus B is an integer, so A minus B is divisible by 9. That is what you have just concluded. But this it should have been the original statement. It should have been the difference, okay, not it. Okay, since A minus B is an integer, so the difference is a multiple of 9, because this whole thing is the difference. This whole thing is the difference. Okay, so just take note. So that's why I said, what is it? Same A minus B. I was questioning that person. Of course, you got your answer. Then this person actually started by saying, let A minus B be. So I started with this. Let A be actually. Let A be in quotes be 10A plus B. Let means that it is not, it might not be the case, but I'm assigning it to it. But that's not the situation. This is this. You don't need to let. Just like saying, oh, let's Nakita be a Form 5 student. No, Nakita is a Form 5 student. We know that, at least the Nakita that I know. Do you get my point? Okay. If I'm trying to prove by contradiction now, I could say, oh, let Jeff be a Form 5 student, because I know Jeff is not a Form 5 student, or Jeff might not be a Form 5 student. So that let statement is you assigning something, assuming something. But here we are not assuming. We already know that A, B in quotes signifies 10A plus B when written in proper form. There's no penalty. It's just correcting certain misconception. What else did I notice here? Yeah, like I said, somebody did the 2 cases, quite impressive. I was a bit scared at first with that question. Would they be able to interpret what this means? And I was happy that you guys did it. Now, this is what somebody did, trying to cheat me again. 2-digit number ABB is divisible by 9. Let PN be the statements, probably trying to use, what's it called now? Induction. Induction was not necessary, but I was ready to read through. So P1 would be when N is, this is not in the case of N. You see, you use induction, and which of course you represent the statement with Pn if N is a variable. In this case, you don't have any the parameter. You don't have any parameter here. You are referring to a generalization of 2-digit numbers AB and its reverse BA. There's nothing like N. It's not like a sequence where you can have, N can change from time to time. No, you don't have that. So you shouldn't have even tried to use it. So this person did, since it's a 2-digit number, N is greater than or equal to 10. What is N actually? What is N? You shouldn't have. So I saw something like P10 equals this minus 0, 1, which is equal to 9, which is 9 times 1. So P1 is true. And I saw P11, which is, okay, not from you guys. 11 minus 11, which is equal to 0, which is 9 times 0. Assuming PK is true. So then I saw something like PKT. Nah, then which is 9x. Nice try. So please take note. Something you use proof by mathematical induction if you are dealing with various, if you are varying the values of N. If the question was maybe AB is equal to NK, for example, and you know that this N might vary, of course, then you can prove it for all N because your N will vary. But in this case, there is nothing like N, so it was not necessary to do that. Did you understand what I just mentioned about this particular error, please? Thank you, Leo. All right. So quickly now, we're almost done. Sorry for those of you that needs to go and eat something. Okay, where are you? So let's go back to the question again. Question 9. Prove by induction that this happens. Many of you started so well. I have to be sincere. Started so well. But again, just like the previous, okay, I think this is the first proof by induction in this paper. Okay. Just like, yeah, this is the first one. Just like some previous proof by induction questions that people have done, there's always a disconnect between the inductive hypothesis and the case N equals K plus 1. So, and as a result, some of you got a 3 out of 7 in that question. So let's begin with the solution itself. Now, this is the solution. Quite short, not too long, right? Remember, I said you don't need to do the case of N equals to 2, okay? So this is what you want to prove. Now, whoever did the error, committed the error that I said, you could see that N is a variable here. N is a parameter, let me put it that way. N is a parameter here that changes, all right? So that is why we can use induction. Okay. When n is 1, remember it is greater than or equal to. Of course, 2 is greater than or equal to 2 is true because 2 is equal to true. Greater than or equal to me is either it is greater or it is equal. You don't have to fulfill both. Either of them is okay. Okay, so this is okay. Then I check the case of n is equal to 2. I got 24 is greater than or equal to 16. Yes, because 24 is greater than 16. So this is also valid. Now I assume n is equal to k. And that is this. It means 2k all factorial is greater than or equal to 2 to power k bracket k factorial squared for some integer k, positive integer, of course. I said, now we prove for n is equal to k plus 1, which means this is what we must get. And you can see how I started. I started from the left. Now this is my left. Okay? Can you see my cursor? I'm moving, please. Can I get 1 or 2 yes? Thank you, Leo. All right, thank you, V. Lady V, like that. Oh, Krista, this is your first response. Krista C. You're so quiet in the class and you're even quiet online. I like that. Oh, Karen. Karen must be busy eating as usual. All right. Okay, quickly now. So you started from the left, right? And we got that, okay? And by our knowledge of, what's it called? Okay, I'm gonna do something. Sorry. Let's go through this together, actually. Now, I'm sure you have that. So my left-hand side, I'm just going to begin from that left-hand side and show you something. So I said left-hand side equals 2k plus 1, no, 2 times that. So let's put a bigger bracket, then 2 times k plus 1. That's our left-hand side, which we expanded to give 2k plus 2 factorial. That's our left-hand side. So when you're proving by induction, you don't bring the right side, no. You work on your left and you arrive at the right. And in each step, you can state the reason why you're assuming something that is not so obvious, which some of you did, okay? So you do not just say left, right, less than. I'll tell you some of the errors that people make. Then we can come back to this slide and see why it is different, okay? So this, using our knowledge of factorial, we can expand this, okay? If you look at the mark scheme that you have right in front of you, I'm just doing the same thing. So this is 2k plus 1, but we don't have anything for that, but rather we have something for 2k factorial. So I stop here. By your inductive hypothesis, which you should have, we had stated that 2k factorial is greater than or equal to 2 to power k, k factorial squared. And what is our goal? As beginners, it's always good to write your goal somewhere. The goal is what I wrote in the so we prove that. So I'm going to put the goal somewhere so I know where I'm going. So I'm trying to show at the end of the day 2k plus 1 raised to power k plus 1, then k plus 1 factorial squared. This is the goal. Okay, so if you have that at the back of your mind, let's see what that can give you. So from here, let's put it here. Okay, so this left-hand side is now greater than or equal to 2. I can even factorize this right away. Okay, factorize that right away. 2 into k plus 1. Then I have 2k plus 1. And I bring this in, 2 raised to power k, k factorial squared. Okay, so I see. Now this is where I'm going, remember, which means I need my k plus 1 squared. Oh, how do I get k plus 1 factorial anyway? My k plus 1 factorial will have been k plus 1 times k factorial. And for me to have square, I must have this in two places. Okay, or the square of this times the square of this, then I can achieve this. Does everybody get that? Can I get a yes or two? Thank you. Good. So if I must have that square, I need to have this square and this square. Why is that important? If you have a squared times b squared, you agree it will be ab all squared. Yes? So if I want to have these two, remember these two will give me k plus 1 factorial. K plus 1 factorial is this. So if I must have it all squared, then each of these must be square. Okay? Okay, good. So if that is my goal, Krista, do your job. Krista is in trouble, I know. Okay, so if that is my goal, I already have one of them. Now I need k plus 1 in square. And if you also look at it, this is actually a combination of this and this. So it's getting there. So which is this one now? For the other one, so which means for this one, yeah, I have one part, which is this. I need this. Now I have one. Okay, so I need to find a way to turn this guy into k plus 1. I need to cheat in quotes. But I'm not cheating. I'm being logical about it. Okay, so all I need to do is turn this one. Well, I can do that. We all know that 2k plus 1 is greater than or equal to k plus 1. I use equal to if k is equal to 0. But we all know that k cannot be 0, so greater than works. Okay, so I'm going to use this to turn this around. Does that make sense? So at this point, you can write using the inductive hypothesis, using this. Okay, that's your inductive hypothesis. For my next step, so I say, well, this is now greater than or equal to 2 into k plus 1 times k plus 1, 2k k factorial squared. Can you see that? And the reason is using this one. Does that make sense? Talk to me, guys. Okay, thank you. Okay, so I put this here. No, it's okay. Okay, so now let's combine it. This and this can be combined. Actually, this left-hand side is equal to, not this line is greater than, okay? So basically, so this implies that left-hand side is greater than or equal to, the left-hand side is this one, okay? If I use greater than here, it's like saying, if I say 8, if I write, I'm trying to tell you why I'm not writing that way. If I say 8 is greater than or equal to 6, then I come here and I say greater than or equal to 2 times 3. Now, what I'm saying is that 6 is greater than or equal to 3 times 3, of course, which is the case because equal to is there. Well, maybe I can write it that way in this case. But if it is just greater than, please don't link it. So you can start with left-hand side again, or you can write in front of it 2 times 3 equal to. As long as you're on the same line, equal to is allowed. If you're moving to another line, you need to be very careful. Maybe it's better you adjust by putting the beginning. Anyway, it won't be a problem here because of the equality. Okay, so remember greater than or equal to. Okay, it won't be a problem because of the equality. So let's continue. Which is greater than or equal to. So I combine these two and I get 2k plus 1. I combine these two, I get k plus 1 all squared, and we already have k factorial squared. So I'm going to factorize this square. So this is greater than or equal to 2k plus 1. So if I factorize this square, I have k plus 1 k factorial all squared. Can you see that? And this is your k plus 1 factorial. So which means your left-hand side is greater than or equal to 2k plus 1, then k plus 1 factorial all squared. This is what you want to get. And this is your right-hand side. You could see this right-hand side only appears on the last line. This appears on the last line. It never appeared at the beginning, which is what some of you usually do. And that is not right. That's not the way to prove. I'll show you some of the misconception quickly. If anybody needs to leave, please let me know. Can always speak this tomorrow if everybody needs to go. I picked this time because I want it to be your most convenient time. I guess I forgot the dinner-ish thing. So please, apologies for that. We have to meet earlier tomorrow so we can spend time together. Then I'm going to activate the audio so you can ask me questions by using the voice. I didn't want it to be too noisy. That's why. So when you raise your hand tomorrow, I unmute your mic. Then you can ask a question. People can gain from it. If anybody wants to suggest something also, you please do the same. Yes, so let's talk about the errors. Somebody who got a 5 in this wrote that left-hand side equals to, after getting this point, okay, decide to write it this way, 2k plus 2. I need you to tell me what is wrong here. 2k plus 1, 2k factorial. Tell me what is wrong here. Anyone? Somebody started with that. Of course, that's not the reason this person got a 5. That's not the only reason, but there's an error here. Can somebody tell me what that error is? I'm waiting. Hello? Brackets. Yeah, should be brackets. Krista started with k plus 1. No, not really. This is still okay. Like, I mean, this step is right. Okay, this step is right. Because actually the beginning is 2 brackets. Sorry about that. The beginning is two brackets k plus 1. And by the time you, come on. Okay. So actually the beginning is this. So I just didn't put that part. Okay. And this is equal to this one. So the problem is this should be brackets. Okay. Yeah. There should be a bracket there. Thank you, Lillian. And what this person also tried to do is to simplify the left-hand side. Okay, got something. Simplify the right-hand side. Got something. And tell me, and trying to imply that left-hand side greater than or equal to right-hand side. No, that's not a good way to go about it. That's not a good way to go about it. Okay? I know, like they say, half bread is better than none. It's better you do something that you won't get the full point than leave it blank. So I get it. If this person had thought, Mr. Daniel wouldn't accept this solution, I'm just going to leave it blank, she will not be getting a 5 out of 7. So sometimes it's better to try than leave it blank. Okay, so that's one error that I noticed. Another error. This is mostly the general problem. This is actually a general, for those that actually struggle with mathematical induction, this is how they prove it. So I got something like pk plus 1 is equal to 2 into k plus 1 factorial is greater than or equal to 2 raised to power k plus 1 k plus 1 factorial squared. Actually, there should be a bracket here. I'll expect a bracket here. Okay. Then the next thing that I saw is this implies that 2k plus 2 factorial, which is of course this one, greater than or equal to 2k plus 1. Oh, actually the same thing is the next thing. Oh, okay, no, this has changed in the next step. Okay, so I have 2k plus 1 factorial squared. This time two brackets were used. And this person claimed this implies that 2k plus 2 factorial is greater than or equal to 2k times 2k plus 1 k factorial all squared. Can you see something now? You see, this person is simplifying the right-hand side for me. And then this person got stuck somewhere, which is the next step. Of course, this was repeated, 2k plus 2 factorial greater than or equal to 2k times 2. Then I got k plus 1. This is quite strange, actually. Then I got 2 raised to power k, k factorial squared, everything divided by 2. Where does that come from? I wonder. And everything square again. Oh my God, there's a factorial here. Quite complicated. Quite complicated. So can you see the error here? Okay, all these are not expected. In fact, from here, it's not expected. This is just for you to note what you want to prove. When you say you want to prove this, you are supposed to just say left-hand side is equal to this, then you simplify it to this, and you continue without mentioning anything here. Okay, does everybody get that? Without mentioning that until you are done. Let's see if there's another error noticed. These two steps are same, so the start and the end are the same. Yes, this is another error. Is everybody there? Thank you. All right. So this is another error. So please take note. I'm sharing this with you so we learn from these mistakes, okay? So p k plus 1, which is the statement to prove. Everybody gets it up to inductive hypothesis, which is the third or the second step. The last step is always a problem. So this person wrote this, okay? Somebody wrote that. And the next thing I saw is 2, okay, k plus 1 factorial, oh sorry, after the second bracket, of course, greater than or equal to 2k plus 1, raised to power, sorry, double bracket, k plus 1 factorial all squared, and I got greater than or equal to k times 2, k plus 1 factorial all squared, and I got therefore 2 k plus 1 factorial is greater than or equal to. So multiplying this back again, k plus 1 factorial all squared. So therefore, for all positive integer n. That's all I have. I'm like, no. You're trying to outsmart me, whoever you are. Okay, so the point is, so I wrote a comment. I said, these two steps, which is this and this, are the same. So the start and the end are the same, and it's not supposed to be. Okay, so this is another mistake. This proof was given a 3 for the previous work done, not for that particular one. So quickly, let's move to, I think these are the most complicated ones. Every other one looks okay. All right, so quickly now, the next question, let n be a square number. Most people that attempted this got a 7. Some were not able to attempt it for some reason, but it's okay, we're all learning. So this is what I was expecting. Since n is a square number, then n can be written in this form, where k will be the square root of n. I've established that from the beginning. The next square number will be k plus 1 squared. And you substitute and you expand. Okay? It's that simple. And short, straightforward, simple. What do we share again? Sitting board. Why do we do this? For anyone who has any question about why we did this. If I pick a square number such as 9, my square number is 16, my square number is 25. 9 is 3 squared. This is 4 squared. This is 5 squared. So if this is my n squared, you could see that n is 3. Then this will be n plus 1 squared. Okay, maybe n will be confusing. Let's use k. Okay. Come on. So if this is my k squared, then this is going to be k plus 1 squared because my k is 3. Okay. If 4 squared was written as t squared, then this will have been my t plus 1 squared. So that's what we're saying. So this parameter that was introduced is actually the square root of the square number. Okay? So if n is a square number, then n can be written as k squared. Then the next square number will have to be k plus 1 squared. And that will be expanded to be k squared plus 2k plus 1. K squared is easy, which is n. 2k means from here now, k will be the square root of n. So we just say 2 root n, and k plus 1 is easy. So can we see that? Very short, straightforward. Any questions? Okay. I believe that's a no. 11. 11 can be done in different ways. So let's see some of the ways that we have done it. Okay. So I did prove by exhaustion. Actually, I started with contrapositive. Okay. The statement says, oh, actually, it is by constructing a contrapositive. You know, I actually gave this to someone who did it using direct proof. My bad. Sorry, I'm going to take up that point. Yeah, so it should be contrapositive. By constructing a contrapositive, prove that if A and B have same parity, then 3A plus 7B do not for all. So do not means do not have the same parity for all integers A and B. And I put a note there. Two integers have the same parity if they are either both odd or both even. So the first thing is to construct a contrapositive. If they have the same parity and these do not, the contrapositive will be if 3a plus 7 and 7b minus 4 do not have the same parity, then a and b do not. Does everybody get that? Okay, that will be the contrapositive. Now, remember, we are starting with if 3a plus 7 and 7b minus 4 have the same parity. So that is your beginning. So you have cases now. If these two are odd, okay, we assume they are odd, and if they are even, so let's take the odd. Now, watch my cursor, please. If this is odd, remember, something plus odd is odd, then the first something has to be even. So 3a must be even. If 3a is even, now 3 is an odd number. For the product of 3, which is an odd number, and something to be an even number, then that something itself must be even. So this is why A is even. That's all you have to explain. Okay? Again, if this is odd, remember this is summation, forget the negative. Because addition is actually subtraction in disguise. Sorry, subtraction is addition in disguise. Okay? I think it works the other way too. Okay, so this is like sum of two numbers is odd, and one of them is an even number. So the first one has to be an odd number. Does that make sense? Now, 7 times something is odd. If 7 multiplies an even number, it will be even. But if 7 multiplies an odd number, it will be odd. So B has to be odd. So you can see that in this case, A is even and B is odd, and A and B do not have the same parity, which is what you want to prove. Remember, the statement is if A and B have the same parity, 3A plus 7 and 7B minus 4 do not. The contrapositive will be if these two have the same parity, then these two do not have the same parity. And that's what you have established for the first case. Another case is when they are both even. Remember, after you have established your contrapositive, you now exhaust all the possible cases. In this case, we have just 2 possible cases. If 7A plus, if 3, how do I keep saying 7 here? If 3A plus 7 is, and these are both even, now let's pick it one by one, and preferably side by side, okay, with spaces equally, equally spaced, neat. I'm not saying OCD++, measuring Pascal triangle. You know who I'm talking about. But anyway, just do something neat. So just kidding. I appreciate all your neat works. All right. So if 3A is, if this is even, remember, this is odd number. What do you add to odd number to make even? You have to add an odd number to it. So 3A has to be odd. So if 3A is odd, remember 3A means 3 times A. Multiple of 3 that is odd, it has to be the odd multiples, okay? Because remember 3 times 4 is even, but 3 times 5 is odd. So A has to be odd. So if you look at the other one, if 7B, if this 2 is even, remember 4 is even, then 7B has to be even as well, because if this was odd, then everything becomes odd. If 7 times B is even, then B must be the even one because 7 is odd itself. So you can see A is odd here, B is even, means they do not have the same parity. So you just conclude by saying in any case, A and B do not have the same parity if this happens. You can see my conclusion is the original statement. Is it? Okay, no. It's my contrapositive. Okay, see, if these have the same parity, these do not. So I'm saying, in any case, they do not have if these have. And I can go ahead and now say therefore, which is okay. But I may not put that because I already said it suffices to show this. That is, instead of showing this, I just show this. So my beginning covers that conclusion if I do not put it. Okay, now somebody did it in a direct proof, which is correct, and I just forgot my instruction and I graded it for that person. I shouldn't have. I will grade it, but it won't be counted because the instruction is clear that only use the method specified except no method is specified. That's the only reason you have been penalized, not because you didn't do the right thing. So somebody did it as direct proof. If A and B are same parity, then this person showed that 3A plus B do not. So if A and B have the same parity, 2 cases are involved. The case 1 is if A and B are odd. If A and B are odd, then this person picks something like 2K plus 1, and B is equal to maybe 2T plus 1. Okay? And picking A and B to be this person substituted into 3A plus 7, and got, this would be 3 into 2K plus 1 plus 7, of course, and got, this would be 6K plus 3 plus 7. This is definitely going to be even because that is 10. So you can say 2 brackets, that would be an even number. Okay, and the other one, 7B minus 4. So we just say, after you get to this point, you just say which is even, something like that. Then this would be 7 into 2T plus 1 minus 4. So which is going to be 14T plus 7 minus 4, which is 14T. 7 minus 4 is 3. So you can say plus 2 plus 1, which is going to be 2 brackets 7T plus 1, then plus 1, which is odd. Okay, which is odd. Therefore, these two do not have the same parity. So if you do it again for the second case, this is case 1. If both of them are even, which means your A could be 2M and your B could be 2N. You can see I use different parameters, all right? Don't use the same parameter, okay? Then you're going to arrive at, the first one will be odd in this case, the second one should be even. It should be a twist like the other way around, okay? and you conclude, oh, in any case, this is what happened. That's a direct proof. But that is not this what the question asks you to do. The question asks you to use contrapositive. That's the only reason that person will be wrong, not because the proof is not correct, because the instruction was not duly followed. Okay? Did everybody get that? Can I get some stuff before we go to the last question? Thank you guys. So last but not the least, that last question kind of give people some problems, and I get it. So like I said, you guys are at the beginning stage of all this, so we do not expect you to think like a professor. Even myself, when I'm talking to my professor, I kind of find it amazed, should I say amazed, how he thinks fast. But then, not because I'm not, smart enough, it's because I'm not experienced enough. So you guys are not as experienced as I will be. So I wouldn't expect you to think as fast as I will be. So please do not blame yourself too much if you think, oh no, why can't I think like that, like Mr. Daniel? The difference is not because I'm smarter than you are, it's because I am more experienced than you are. I learned this before you, not because I know it better than you do. All right? So please, if you are still finding it difficult to think fast, with more practice, you'll get there someday. So last question, let's quickly go to that so we can all go for food. Then I can go back to my Netflix. If A, B, and C are all odd integers, prove that ax squared plus bx plus c equals 0 cannot have a rational solution. I've seen different approaches, okay? But let's go to the main approach. Let me use my mark scheme first. Then I can shed in more light. Okay. Come on, where is it? Okay, here is it. Now, if these are odd numbers, so I use contradiction. Suppose on contrary that it can have rational solution. Remember, the statement say cannot have a rational solution. I just said it can now have a rational solution. I still maintain the if part. That's one thing about contradiction. You leave your if part the way it is. You only change the outcome. So your if part is the same. And so suppose I maintain this condition and I arrive at a different result. That's the point you are trying to make. Okay? So suppose these are still odd integers. However, the equation now has a rational solution. Okay? A solution. You don't need two solutions. Just one solution is sufficient. Somebody did it by using two solutions and did something. I'll share with you that solution. And I think I gave the person a full point, even though we do not need to go to that extent. But it was, okay. And I thought, okay, why not? For at least thinking this way. So we said, suppose you can have a solution, say P over Q, where P and Q are co-prime, which is what we mean by the GCD is equal to 1. Then this happens. Being a solution, it means when you substitute, it should satisfy the equation. So we substitute, we got that, and we simplify, we got to this point. Okay? So now, since A, B, and C are known to be odd, we consider the following possibilities for P and Q. We do not have possibilities for A, B, C. We already have it in the hypothesis, which is A, B, and C are odd, all right? So the possibilities are on P and Q. What can we say about P and Q? They have the same parity, or maybe they do not have the same parity, okay? If they have the same parity, maybe both of them are odd, or both of them are even. If they do not have the same parity, maybe P is odd, Q is even, or the other way around. So I consider 4 cases. Case 1. Case 1 and 2 is when they do not have the same parity. If P is odd, but Q is even, let's go back to the problem. The first term of the equation, so go with me with the cursor. Can you see the cursor, please? Thank you. All right. If, remember, A is odd. Now, if P is odd, this term, odd times odd, because odd square is odd times odd is odd. So the first term is odd. Okay? Q is even. When even multiplies anything, it becomes even, irrespective of what the other one is. Okay? So this is even. Now, C is also odd, and Q is even. Q square will be even. Then this term automatically become even. Even plus even is even, but odd plus even is odd, which means this odd term multiplied by this sum will be odd. How can an odd number equals 0? We have a contradiction there. So that's why we said this. So this is why I said AP square is odd, this is even, and this is even, which implies that this sum is odd, which is a contradiction since right-hand side is equal to 0 is not odd. Right-hand side is 0, and that is not odd. So that's a contradiction. Let's check the second case. If P is even, if this is even, first term is even, middle term is also even. Now, if Q is odd, remember, C is odd from the hypothesis. Q square will be odd as well. Odd square is odd. Odd times C odd times Q square, which is odd, is also odd. The sum of the two even remains even. So even plus odd will be odd again. That's another contradiction because your right-hand side is 0, and that is not an odd number. Okay? In the third case, if both are odd, there's a reason I left the last case as the last case. If both are odd, then what happens? Let's go back to the equation. So if P is odd, remember A, B, C are still odd. Odd square is odd. Q square is also odd. So this term and this term are odd numbers. The sum of the first and the last is odd, which is even. This middle one is also odd, because odd times odd times odd will be odd. So odd plus odd is even, plus odd is odd, and 0 is not an odd number. So that's a contradiction. The last one, if both are even, in fact, that is a trivial contradiction. If both are even, it means both can actually be written as 2x and 2y, or maybe 2m and 2n, which means at least 2 is a common factor. And that is not supposed to be the case. Remember, the GCD of both P and Q is 1, which means there shouldn't be any other common factor other than 1. And if the fourth case is the only valid case, but that is the only case where the left-hand side and right-hand side can make sense. Remember, right-hand side is 0. You must always get a 0, an even number on the left to at least make sense of it. Whether the left-hand side is a 2 or a 4 is another case entirely. But if left and right have the same parity, then it's still a sensible statement to some extent. Does that make sense? So if both odd P and Q are even numbers, it means at least 2 is a common factor, which contradicts the fact that P and Q are co-prime. And that is why the last case is also leading to a contradiction. That's why I said, since all the 4 possibilities lead to contradiction, then our supposition must have been wrong. And what is our supposition? Maintaining A, B, and C to be odd, and saying that the equation has at least one solution, which is a rational number. That must have been the wrong one, the conclusion we had in the beginning. So if that conclusion is wrong, then the original statement is proved. Does that make sense, please? Okay, so let me see if I have certain comments. Please let me see your notification if what I said now makes sense to everybody. That will be the last one. Once I share this feedback, please signify if you have questions. Hello, everybody get that? Okay, thank you. Thank you, thank you. Thank you guys, very good, thank you. I thought Krista was supposed to go and eat. All right, so some feedbacks Okay, sorry, I'm gonna release you in say like 3 to 5 minutes, except anybody wish to ask me questions. Of course, if you're tired of seeing my face, I'll let you go. Some feedback from some solution. Okay, here is a solution that was awarded a 3. When I'm done checking the others and I see something that I haven't mentioned, I will mention them before we begin our class proper tomorrow. Okay. This one has a 7, then there's no need. Okay, this is just a grammatical error. It suffices to show that, actually that's not for number 12. A and B does not, I said A and B do not because it's a plural now. Anyway, so that's not a huge comment. Okay, so this was given a 3, so please listen. I'll go to the stuff now. The whiteboard. Okay, here we are. Okay. So I got this. If these are odd and this has no rational solution, a odd number is 2n plus 1. Okay. And I got something like rational number is m over n. Okay. Assume on contrary, this has a rational solution. So this person substituted m over n, like I substituted p over q, and this person got to this point. So m over n is the number substituted, like I said. So I got something like a m squared plus bmn plus cn squared divided by n squared is equal to 0, which isn't necessary. Actually, this is from, am square over m squared bmn, right? Yeah, bm over n, yes. Then c is equal to 0. From here, from that step, you should have just cleared the fraction. Okay, this is what I mean. In case I'm confusing, I skipped that step. Apologies. Quickly, let me quickly go through it. The idea is for you to please avoid these errors in future solutions. So substituting that. What's that? Okay, that's way better. Okay, so from am squared over n squared, then bm over n plus c equals 0. So this person was able to reduce and got am squared plus bmn plus cn squared divided by n squared is equal to 0. I said this is not necessary because from here you can clear the fraction. You can clear the fraction by multiplying through by LCM, which is n squared, okay, from this step. So you don't need to go through this. Okay, now after getting to this point, then I got something like if n was odd and m was even, the solution would be even. No, there's no proof that the solution would be even. I'll give you an example. I got something like, okay, if n was even and m was odd, let's see, n even, let's say 4. M odd, let's say 3 or 5. The solution m over n is not even. Okay? In this case, I have either 5 over 4 or what? 3 over 4. Neither odd nor even. It's not even an integer. Okay? And only an integer can be classified as odd or even. So that argument, so it will not be a rational number, so it can be divided by 2 now. And that was the end of the solution for this person. I guess he or she got stuck and didn't know what to do next. Okay? So that's that. That's one error here. Does everybody get that? So we don't need all this, okay? You can go through with the one we did before. You don't need to waste your time with all this, okay? That argument was wrong. So for up to that point, I gave that person a 3. out of a 7. That's what I keep saying. At least do something. Let's know you are trying to connect with something. If you put your the hypothesis right and some other stuff, you'll get some points. This was awarded a 1. Suppose on contrary, it has a rational solution. I said which is what? Because this rational solution was not stated. Okay? I only got suppose on contrary, it has a rational solution. What is a rational solution? It wasn't stated. Then because the assumption is that A, B, and C are odd, I got A is 2m plus 1, B is 2k plus 1, C is 2v plus 1. And I said no need for that step. Because what this person ended up doing is to substitute all these 2k plus 1, 2m plus 1 into the original problem. And it becomes so complicated and this person could not even proceed. So I just awarded a 1 for at least stating the contrary of the situation. Quickly, this was awarded a 2, okay? So this person claimed, oh, let A be 2m, a contradiction now. Suppose it has a rational proved by contrapositive. Remember, the question does not say use contradiction. So you are free to use any method you want. I only stated in my own mark scheme a contradiction, okay? So this person is trying to use contrapositive. The contrapositive of the statement will be that, remember, this is like if A, B, and C are odd, this equation has no rational solution. So the contrapositive will be if that equation has a rational solution, A, B, and C must be even. So this person said, if that has a rational solution, A, B, and C are even. Very good start. Okay, so the if part is that it has a rational solution. The then is that A, B, and C must be even. Now, guess what this person did? You want to prove that A, B, and C are even. This person started by let A be 2m, let B be 2n, let C be 2q. So you started from the result. That's not supposed to be. You are not supposed to start from the result. You want to get that. You have decided to use contrapositive. Start from the fact that it has a rational solution, which is like this. Once you clear the fraction, now show that this and this and this has to be even. Okay? So this person, at the end of the day, could not proceed properly because it doesn't even make sense. You start from your result and trying to do what? Eventually, this person only got 2 brackets, something. Let me see. I can't open any further slides, so I have to make use of this. This is the last one, actually. So eventually, I got something like 2 brackets mr squared plus nrs plus qs squared equals 0. And the comment was, this is true, since left-hand side is even and right-hand side is also even. Yes, but this even could have been 8. And 8 is equal to 0 does not make it reasonable for us to accept. Does everybody get my argument there? You guys understand why I am not okay with that conclusion? Aha. So I wrote a comment. You have attempted to use contrapositive, but not used quite well. You are trying to prove if that has a rational solution, then A, B, and C must be even. You must begin with the rational solution, say R over S, where you have to state the condition also. Okay, then substitute and establish that this leads to A and B being even. In your proof, you had also assumed A and B are even alongside the rational solution, which is not supposed to be. So if X is that in the dispute, you can blah, blah, blah. Okay, and I wrote something here. If X is R over S, which is the assumption, just like X is M over N here, is put into the equation, you will get, so I told the person what you will get, which is the simplified form of the problem. And it might be complicated to show that A, B, and C are even. Yeah, I think that would be too difficult for you to work around with. Of course, I'm happy to see if anyone can try and give us an argument, concrete argument to show that A, B, and C will be even. And I said, see the mark scheme for easier method. Okay, so I left a note for that person. That the last one, yeah. I'm impressed with this. I gave this person a 7. This is the last one. This person said, suppose A, B, and C are blah, 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 then these are blah, blah, blah. Okay, this is the question. Now, this person is using contrapositive. No, contradiction, sorry, contradiction. Yeah, contradiction also. A, B, and C are odd, but this has a rational solution. But in this case, this person is assuming 2 rational solutions. So this is the one I was talking about from the beginning. 2 rational solutions, which is not necessary, like I said. Only 1 rational solution is sufficient to justify your proof. Okay? So this person claims that let the equation be, because if we say the rational solutions are S over R and M over N, so this person claimed actually negative. I don't know why negative. That let I saw something like let AX squared plus BX plus C equal to 0 be RX plus S brackets CX plus U equals 0, where R, S, T, U are integers. I like that. Such that this is equal to 0 implies, then there was some expansion. So eventually, are you following this? Eventually, this person got RT X squared plus RU plus STX plus SU equals 0. Eventually, this person got this and decided to compare with the, we already said let this be this. The reason we are letting this be this, according to that person, is because we have assumed that there are rational solutions. So basically, this person is trying to tell us the rational solutions are minus S over R, minus S over R, and minus U over T, basically. But the person did not state that. But I assume that's what this person is trying to communicate. So next time, you can say, let the rational solutions be this. If the rational solutions are this, then you say, oh, the equation will be X minus, actually the plus is better. Then you say X minus this and X minus that. And if you want to use this, then you can make use of the plus here equals 0. It's all right. Then you expand, not just saying let this be this, which is okay. This is also okay. It means when I factorize this, let it be this. Your rational solution will only be this because it is factorizable, of course. Yeah. So this is allowed. I'm just saying you could also do this. I'm not saying this is wrong or this is better. This is perfect. Okay. So this person decided to compare with Bx plus C equals 0 and concluded that A must be, are you following this? Okay, you can see what this person is trying to do. So I concluded that A must be this, B must be that, and C must be that. Remember, this is contradiction. A, B, and C are odd, and this equation has rational solutions. So this person is trying to arrive at a contradiction here. Now, he or she now said, who's that? Oh, E. He now said, A and C are odd. I like this argument. So I give this person a 7, like I said. A and C are odd. So RT and SU must be odd. Remember, this and this are the same. So this and this and this are the same. So if this is odd and this is odd, then this is odd and this is odd. Okay? So what else? An odd number added with another odd number gives even. So this 2 is even, which means these 2 terms are even. That's what this person is trying to tell us. Okay? Then an even number. So this gives, B is equal to that gives a contradiction. So what this person is trying to say is that, what this person is trying to say is that if this is odd and this is odd, well, the only problem I might have with this is we're talking about the term. Does everybody see what I'm saying here? We're talking about a term. If A and C are odd, then this must be odd. Yes, that is allowed, which means this plus this. But what about the x squared term? What about the x squared term? Because we don't know anything about S, or maybe this is or this is even, maybe both of them are odd, maybe, things like that. So that is the only issue I might have with this problem. Of course, I marked it for this person, but I think the last conclusion is not so convincing. So what this person is trying to say is that, oh, this is odd and this is odd. He has assumed that this is odd. I mean, everything here is odd, everything here is odd, so these two must be even. So now, this being odd then creates a contradiction because B must be odd. It means you have already assumed, something for the old term. What about the X term? Do you understand my doubt? Please signify if you understand the doubt that I have in this conclusion. But for the question, isn't it concerning A, B, and C? So it doesn't matter. Yes, yes. But remember, okay, Mr. Cheng, let me see, where's our chart? Ethan? I need you to do something for me. Where is he? All right. Mr. Cheng? Can you hear me? Hello? Okay, can you say something? Speak, maybe I can hear you.
Wait. Do you hear me?
Yeah. Can everybody hear him? Okay, great. So explain what you mean.
Oh, wait, so like, with the question it says that if A, B, and C are all odd integers, proves that ax squared plus bx plus c equals 0. Right? So it's not our ax squared odd, our bx odd, and our c odd. It's just A, B, C.
Yeah. The focus is on A, B, and C. I get that. My point is, in this argument, A is being compared to RT, B is being compared to SU, and B is being compared to RU. Okay? So this argument, we do not know anything about S, R, U, and T, except that S and R has to be co-prime, U and T has to be co-prime. That's all we know. Okay? So saying that since A is odd and C is odd, RT must be odd, SU must be odd. How does that really give us a contradiction? Because what this solution is trying to do is to say that left and right give a contradiction. Your right is already an even number, right? You are trying to show that this will give an odd number, then a contradiction. If you want to do that, you have to consider everything on that side, which means if you claim, oh, this must be odd, we need to know something about this. We do not have RT plus RU plus ST plus SU is equal to 0. That's not what we have. If that is what we have, then we can say, oh, since this is odd and this is odd, these two must be even. And since this is odd, then it is a contradiction. This is not what we have. Does everybody get my point? We have an x squared term and an x term here. Okay, so to be able to justify that indeed A, B, and C are odd, and trying to bring a contradiction, you must be able to use a complete expression that justifies it. Trying to say that, oh, because this is as good as not even coming to this point. If I'm to accept this fully, of course, this argument makes sense because I had to look at it critically. I mean, it makes sense to some extent, don't get me wrong. If instead of going through this, then I've just been wasting my time coming here. I should have just come from here and say, oh, since this is odd and this is odd, these two must be even. Then because this is odd, I have a contradiction. Do you get my point? If I have to accept this, then why can't I just conclude from here? Do you get my point now? Is it here?
No, not really. Can you say that again?
All right. If I have to accept this conclusion, the conclusion is, oh, because A is odd, this is odd. Because C is odd, this is odd.
Yeah.
Because the sum of two odd. The sum of two odd means the sum of A plus C. But that's not what we have. We have here, you're trying to get a contradiction at this step, isn't it?
Mm-hmm.
We have here AX squared plus C, not A plus C.
Mm.
Do you get that now?
Wait, so you're saying that the reason why this doesn't work is because with this logic, like A and C added together would then be an even, and that's why B like is also even, and that's not like a valid argument.
No, that is a valid argument, but that's not what we have on paper. What we have on paper is this. What we have on paper, let me take this off. What we have on paper is AX squared plus C, not A plus C.
Yeah.
Do you get that now?
Okay. Mm-hmm.
So if this is even, this may not be even.
Wait, no. So A is R and T, right?
Yes.
And so if R and T are odd, that means that R, since when you multiply two odd numbers, you get an odd number, right?
Yeah.
And so with C, it is also assumed to be an odd number.
Mm-hmm.
So that means that odd number S and odd number U would also create another odd number, right?
Mm-hmm.
So that's why we can say that both S and U are also odd numbers.
Mm-hmm.
So from that, we can kind of conclude that R is an odd number, T is an odd number, S is an odd number, and U is an odd number, right?
Mm-hmm.
So with that being said, R and U are both odd numbers. So when you multiply them together, it'll get you a 2n plus 1 number. And when you multiply S and T, you will also get a 2n plus 1 number. Perfect. And when you add those together, you'll get a 4n plus 2 number, which is then also which is then an even number.
But B is odd.
Yeah, that's the contradiction. Good.
Now I accept it. What I thought you are trying to say is when you had these two, you get odd. Does everybody get its explanation now? I guess that's why I was a bit somehow in the solution, but I knew, the logic. Hello, can everybody hear us? All right, so its explanation is now totally accepted. So what it's trying to say is this. Now I get what it's saying. It's not comparing the old term. It's just focusing on these parameters that he introduced. Okay, so let me just recap so that everybody is on the same page. So very good argument, very good argument. I like that. So if A is odd and C is odd, this must be odd and this must be odd. So A equals RT is odd, C equals SU is odd. Now this is product of two and you get odd, so each of them must be odd. That's the only way you can get odd number. This is product of two and it is odd because C is odd and it must be, each of them must be odd. So S is odd, U is odd, R is odd, T is odd. So now if you come to the middle one, RU remember this is odd and this is odd, then this must be odd. ST, remember this is odd and this is odd, then this must be odd. Odd plus odd should be even. If this is now B, remember B is odd. Odd and even is a contradiction. So perfect now. Now the solution makes sense. I guess the way it was written was what confused a little bit. So this makes sense now. So this is another way somebody has done it. So I'm only trying to tell you that there are other ways we can actually argue, as long as your argument is well explained, even if at the point of marking you were given a lower point, once you're able to defend your argument, then everything is good. Any question from anyone? Just tell me no if there are no questions. And if you have questions, raise your hand, then I can unmute you, then you can talk to the whole class. Your feedback will be sent tonight. You'll get your feedbacks tonight. Okay. Any other question from anyone? Okay. All right. So tomorrow, can we agree on time, please? Let me see if the noise will not be too crazy if I unmute everybody. I don't want to be people are not able to communicate. Let's conclude it. It will be better. Right? 2 p.m. How long will it be? We can make it a short class, like one is okay. 1 hour. Drinking coffee and that's that. What is that? Is that a TV? Yeah, whose TV is that? Okay, thank you, whoever that person is. Can everybody hear me now? Okay. All right, so you can mute yourself if you think your TV is loud, but I unmute everybody so you can talk to me if you want. Yes.
How about we do after lunch? So like around 1 or 2.
Somebody saying 10, somebody say after lunch. Okay, yeah, after lunch. Okay, Nakita said 10, now she's okay with after lunch.
Because I feel like if it's at 10, some people might not be wide awake.
Yeah, like me. Like you and me.
So I don't think like I'll be able to process things properly.
Yeah.
Like that early in the morning, you know?
Very agreed as well. She must be one of us, the sleepyheads.
So maybe like 1 or 2.
Okay. Everybody okay with 1 or 2? 2. All right. Yep. 2. Okay. Everybody okay with 2? Good. All right. So 2 p.m. tomorrow, we do 2 to 4 latest 2 to 4. Is 2 okay on every day that I want to have you online? Because I'm going to give my form 4 some other time. I think the P6 babies can be in the morning, like 10 or 11. Yeah, Monday to Friday. I can give you a day off. Yeah, they're gonna have to have classes. Yeah, you have to have classes. I sent them some worksheets to do online, but you know, sometimes they need help with how to do this. So, and thanks to Zoom and ability to write on the screen, so weekdays is fine. Vienna does not want weekend. What's going on weekend? Library, bookworm. Saturday I'm busy. Sleep. Calista sleeps on Saturday. Other things like what? All right, just kidding. So we do Monday to Friday, 2 hours, 2 to 4. Let's see how fast we can go with that. Okay. I work on the worksheet stuff. So send it to you ahead, and we're good to go. And sometimes I might give you something to do. I will expect you to submit online by showing me your attempt. Just the way Krista sent in picture, you will send in picture. I think I would rather you send the picture on WeChat where I can easily open it. Sending the picture on this application means we have to first download, but on WeChat we can actually just view, I think. We don't have to download, save on the computer, okay? So we'll be using both platforms, right? Any other suggestion on question? If there is none, we will meet tomorrow by 2 p.m. Thank you very much for your time, and I'll see you tomorrow. Well, I'll hear from you tomorrow. I can't see you technically, but you can see me. Okay, bye. Have fun. Mr. Chang, thanks for letting us hear your voice. Okay. Now let's stop the recording first.